Hello guys, my name is Gustaph Modimi Mukete, doctorate student at California Intercontinental University. Today our discussion will be centered on building information systems. We'll be looking at a 6-item agenda today. First, we'll look at the definition of information system. We'll see what an information system is briefly. Secondly, we'll see building systems and organizational change. Third, we'll look at core activities in systems development. Next, we'll look at systems design methodologies, and then we'll move to alternatives for building information systems. And finally, we'll look at the new approaches in the digital era. So when we talk about an information system, what really is an information system? So an information system is a formal socio-technical organizational system that is designed to extrapolate or collect, process, store, and distribute information within an organization. When a new information system is being built or crafted by every company, obviously there is an impact that goes to the organizational change side of it. So how does building information systems affect or impact organizational change? First, we want to say that the building of information systems involves much more than hardware and software. So it goes just beyond hardware and software development. We have a people component part of it. We have a change management segment, which relates to the people or the business users who have to accept these changes coming either from the hardware or the software component side of building an information system. Next, it also includes changes in jobs. New skills have to be developed, management styles have to change, and the organizational style has to change as well. And the next thing we want to talk about here is the building of information systems as it impacts organizational change comes with automation. So organizations usually automate their processes which were previously done manually. And we have also something we call rationalization. We also have business process redesign and paradigm shift, which comes as a result of building information systems. Building the redesign process. First, we begin with identification of the process that needs change. So you have to sit with the business to understand the process that needs to be transformed. So when you understand the process that needs the transformation or the change, next you want to analyze the existing process. So this usually comes with the as is and to be analysis. So you look at what the current system is actually doing, what the current functionality is achieving, and then you look at what the business seeks to transform or what the business seeks to achieve. So you analyze the existing process in order to gain an insight into how to transform that current process to a better new process. So when that analysis is complete, the next step is to design the new process. You get into the actual designing of the new process. This typically involves the crafting of functional and technical specifications. What do I mean by functional and technical specification here? The functional specification here captures the business process. For example, if it's the order to cash process or procure to pay process, you need to understand how the business is currently handling each of these processes step by step. And then with the technical specification, you are transforming the business knowledge or the business acumen into a more technical understanding or a more technical foundation for the developers to be able to craft or design any necessary logic that will be required to achieve the new development or the new system that needs to be implemented. So when the design process is complete, we move into the implementation phase of the new process. This process usually involves developers, functional consultants, and key business users or super users who facilitate the development or the implementation of the new process. And the post-implementation step here is continuous measurement. When the new process has been implemented, you want to understand or you want to make sure that the business is actually getting the required results. So the business is getting what the expectation was prior to the design of the new process. So this is a key process, not just to the business, but also to developers, consultants, and every person who is taking part in the design of any new information system or any new business process. Now we want to take a look at the key tools for business process management. So what are these tools? We've talked about business process redesign, reengineering, but we want to understand now what these tools are. What are the tools that we use to transform these business processes? First, going back to uh, the history of or the background of business process management and the tools that are involved. We have over 100 software companies providing tools for business process management. And what is the purpose? What is the function of these tools? These tools facilitate the identification and the documentation of the business processes that need change. They also enable the capturing and the enforcement of key business rules involved in this BPM process. They also facilitate the integration of existing systems. So for example, if we have a Salesforce system, we have SAP system, or we have Wide Orbit, Windshuttle, these tools help in the integration of these systems for better communication, for better facilitation of transformation or transmission of business information and processes. They also provide analytics, like SAP provides the analytics module, which facilitates the conduction of analytical processes within the BPM realm or ecosystem. One of the key examples of tools that are used here, we have the most popular in the industry, like IBM, we have TIBCO, we have Oracle, and we also do have SAP. There are many other tools, but for the purpose of this presentation, we'll mention just these few. But you can also do research to find out more about some of these tools that are widely used in BPM. What are the core activities in systems development? So systems development involves systems analysis, systems design, programming, testing, conversion, production, and maintenance. This picture here is similar to the ASAP methodology, which is widely used in the implementation of multiple SAP projects across the globe. So we'll get a little deeper into understanding the key activities that happen within each of these steps in the systems development life cycle. So what are the key activities that happen in the systems development lifecycle here? So the first step is systems analysis. What is systems analysis? By systems analysis, we mean the identification of problems, the specification of solutions, and the establishment of requirements. So this step is very critical in every development life cycle because it establishes the main point for creating the business requirements document, the BRD. So the key activities here, first we have to identify what the problem is. So what problem is the business currently facing? Why is the business requiring transformation or change? So when the problem is identified, the next you want to design that solution. You want to specify that solution to the business. When the solution is specified and presented to leadership, you want to be able to establish the requirements. So the business has to work with the techno-functional team to align the requirements. So when you're aligning the requirements, you are setting pace for the development of the change, development or implementation of the change. So I want to mention here that when we are getting involved with implementations that attract third parties or outsourcing, this is very critical because the statement of work or the SOW has to capture every requirement, make sure that there is no gap with what the business is trying to achieve and what the implementation partner has to deliver. The next step here involves system design. What is system design? With system design, you are creating the design specification. So here we are stressing on two types of specifications. Like I mentioned earlier, the functional specification and the technical specification. What is a functional specification? Functional specification is a functional understanding of the business change. What is the business trying to achieve? So you're transforming the business knowledge into a functional acumen which will facilitate the development of a technical foundation. When the functional specification is designed, then the technical specification has has a better foundation for its crafting. So I'll take, for example, if a business in Italy is trying to implement electronic invoicing, in the systems design phase, the functional consultants or users need to identify the inputs and the outputs both in the active and the passive cycles. That's the accounts receivables and the accounts payable components for electronic invoicing. So how are the customers getting their invoices currently? How are the vendors receiving their invoices? All of that has to be documented in functional terms, and key tables or key components, systems components that need to be tampered with. So all of this information helps in the design, the technical design of logics or key objects or key tables that need to be involved or that need to be mapped into the schema which will capture the entire business process. So when the systems design is complete, we want to get into programming. Programming is simply the transformation of the technical jargon into a programming language. A common programming language used, for example, in the world of SAP is the ABAP4, which traditionally runs on Java. So in the programming segment, we are translating those technical requirements or the techno-functional requirements into computer codes, into simple computer codes, which will enable the delivery of the business expectation. So what is the post programming step? That's testing. This is another very key step in every systems development lifecycle. We have three kinds of tests here. First, we have unit testing, which is usually conducted in the development server. We have systems testing, and we also have the user acceptance testing. I'll talk briefly on each of these testing types. With the unit testing, this is commonly done by either the functional or the technical consultants or engineers. What happens here is you are trying to test in the development environment if your programming or the codes or the configurations are working as expected or delivering what the business expectation is. User acceptance testing involves identifying key business users in the respective business segments that are impacted by a specific development or enhancement. So in our example for electronic invoicing, you want to identify key business users in the accounts receivables on the accounts payable segment of the business to conduct the activities that they usually conduct to ensure that everything works as expected. And it is also worth mentioning that user acceptance testing or UAT is normally conducted in the quality assurance environment or the QA environment. So when everything works as expected in the quality environment, you want to move those changes or migrate those changes into the production environment. What is this whole migration process? By migration here, we mean that we are getting the configurations, the codes, the programs that have been implemented from the development environment right up to the QA environment to the live or the production environment. I'll take an example here with SAP. Usually, some companies use tools like the Hewlett-Packard Quality Center, where you create the test scripts in the Quality Center, you upload those test scripts, and then the users have to run those test scripts. And when the users run those test scripts, they can either have a successful or an unsuccessful run. So when the run is successful, the user gives a pass. If it's unsuccessful, then the test needs to be rerun to make sure that everything is captured and everything works perfectly well. Again, in the world of SAP, one of those activities that happen here is an approval coming from maybe quality assurance engineer or a QA lead. When the QA lead approves that test, then we'll have someone from the basis team, SAP basis team. It can be an SAP basis engineer coming in to transmit or to transfer these changes from the QA environment into a pre-production or a production environment. How is this done? This is typically done by SAP transaction codes. First, SC9 or SC10, the transports have to be released in the quality environment, and then transaction code SCC1, which is typically used to migrate those transactions or those transports from the quality environment to the production environment. Another approach is using the STMS transaction in SAP to move these transports from the quality environment to the production environment. The next step here involves conversion. What do we mean by conversion? Conversion here simply means that we are getting all the data. It might be transactional, master data, or whatever type the data might be. We are converting that data from a legacy system into the new system. For example, if we're migrating from Whiteout into SAP, the conversion process will be extracting those details from the legacy system into the new SAP system or the new information system. We have what we call plant conversion, and there's a lot of documentation involved here as well as user training. So the users have to be educated on these new changes because this impacts their roles. They have to be trained or made understood of the new transaction codes and how these transaction codes flow. If it's something related to journal entry postings, these users need to be trained on how to execute these postings or how to run bad jobs, how to monitor job failures, how to make corrections, and many other requirements that might come in. So the final step here is production and maintenance. With production and maintenance, here we are assuming that everything has moved smoothly from the systems analysis phase right up to the conversion segment of the system development lifecycle, and the system is good to operate. So the system is operating. If we know that the system is operating properly, we want to evaluate the system again and then accept any modifications or enhancements coming from the business. This also ties to what we call the hypercare or maintenance phase of the software development or engineering lifecycle. Next, we want to see key systems design methodologies. So we'll begin here with the structured methodologies. What do we mean by structured methodologies here? These are process-oriented methodologies which focus primarily on the modeling of processes or actions that typically capture, store, manipulate, or distribute data in an information system. So these structured methodologies have been adopted or used typically to document, to analyze, and design information systems since 1970s. So this methodology dates as far back as the 1970s. Although we have new methodologies that are coming up which promote faster deployments of softwares in the engineering space, but it is worth mentioning that this dates as far back as the 1970s. Another thing worth mentioning here is the fact that the primary tool for representing or designing these structured methodologies is the DFD or the data flow diagrams. So data flow diagrams are just diagrams that are understood by engineers with different shapes and different meanings, or different shapes that capture different languages. So these data flow diagrams are used to create a pictorial representation of processes or systems improvement in the software development life cycle. The next systems design methodology we want to see here is the object-oriented development methodology. What is OOD? Like you see on the diagram on the right, which has cohorts of employee, salaries, hourly and temporary. So this uses objects as the basic unit of systems analysis and design. In the engineering space, object-oriented development combines data and specific processes. It is also worth mentioning that OOD is based on concepts of classes and inheritance, like we see on the diagram on the right hand side. Next, system implementation is achieved by translating this pictorial representation into programs or computer codes, like we earlier mentioned. Also, this approach or methodology has the advantage of reducing the time and the cost of writing software programs due to the ability to reuse software objects. So if a software object was previously created to handle a specific business process or change, with the object-oriented development methodology, it is also possible to reuse this object to achieve another business change or process improvement. Now let's have a discussion on the alternative methods for building information systems. So apart from the other methodologies, the other, I'll call it traditional methodologies that we already saw, there are other methods that we can use to build information systems in the realm of information technology or software engineering. So we have the traditional systems life cycle, we have prototyping, we have application software packages, we have end user development, and we also have the outsourcing methodology that is used to build information systems. So what are the new approaches in the digital era here in systems development methodologies? First, we have the rapid applications development. Next, we have the joint application design, or JAD. And then we have the agile development process, which is a more rapid methodology which guarantees smooth and fast deployment of software changes or software enhancements within a very short period of time, numerous iterations, and very economical as well. So apart from the rapid applications development, joint applications design, and agile development, we also have the reusable standardized software components in the digital era, which is adopted or being embraced by numerous companies as well across the globe in the implementation of business process changes. Once more, thank you guys for watching, and feel free to email me any questions. Thank you.